Hi all, today we start discussing numerical analysis. It is the last two modules of your mathematics course for this semester. In this video, I would like to convey the role of numerical analysis in the various branches of mathematics. Numerical analysis is the area of mathematics that creates, analyzes, and implements algorithms for solving numerically the problems of continuous mathematics. Numerical analysts and applied mathematicians have a variety of tools which they use in developing numerical methods for solving mathematical problems. An important perspective which cuts across all types of mathematical problems is that of replacing the given problem with a nearby problem which can be solved more easily. There are other perspectives which vary with the type of mathematical problems being solved. For example, to evaluate a definite integral numerically, begin by approximating its integrand using polynomial interpolation, then integrate exactly the polynomial approximation. That is, suppose we have a integral minus 1 by 2 to 1 by 2, this 1 by 1 minus x dx. Suppose we have this integral, the problem is to evaluate this integral. We know that this 1 by 1 minus x is x can be written as 1 plus x square, x plus x square plus x cube plus etc. Okay, which shows that of course this is true for every x is less than 1, and we know that what is the meaning of this. If we choose the polynomials like 1 plus x, 1 plus x square, etc., then these polynomials will converge to 1 by 1 minus x. That is the meaning of this equation. Okay, so we know that this is a GP, then the sum of GP is nothing but 1 by 1 minus x, if x is being the common ratio of this GP. So this is a problem. So if this is not easy to evaluate, you can evaluate the integrals of these polynomials minus 1 to 1 1 dx, or you can evaluate minus 1 to 1 minus half to half 1 dx, or minus half to half 1 plus x dx, and so on. Okay, so we know that if we consider these integrals, the integrands are very simple polynomials to evaluate these integrals rather than this 1 by 1 minus x. So if you choose these integrals, we can say that these value is going to be the value of this one. Okay, so of course this requires the help of a computer to evaluate these integrals up to a stage. Okay, if we need to consider 10 numbers, it is easy to evaluate using manual effort. If you have to evaluate 10,000 integrals, then you must need a computer or help of a computer. So the numerical analysis includes the help of a computer to evaluate the things and to get the better approximation. So this is the meaning of this statement. If in order to evaluate this integral, if this integrand is not so simple, you can consider the nearby problem. Nearby problem means if you consider these much polynomials, then the integrals are so easy. Okay, the integral can be easily evaluated. So for these polynomials, so you evaluate, you consider this problem, you replace this problem by a nearby problem of solving or integrating polynomials. Okay, then we can approximate this value of those to this one. Okay, so this is one of the one way of using numeric analysis. Okay, that is, if you cannot solve a problem directly, then we replace it with a nearby problem or simple problem which is very close to the real problem and which can be solved more easily. Okay, so this is the basic idea of numerical analysis. And now we have some areas or branches of mathematics in which this numerical analysis used. So the first thing is numerical solution of system of linear equations. So that means in order to, suppose we have a uh, function like this is f is equal to f of x, or y is equal to f of x, then in order to evaluate the 0 of this polynomial, or the value of this polynomial here, or suppose we have a function is like this, suppose we have this is our c, then in order to evaluate this value, this is our f of some x, or f of a if this is a, and then suppose we have this graph, and the one problem is if this graph is like this, then we can say that this is a 0 of this polynomial, this function y is equal to f of x. Okay, so in order to get this root, we calculate the tangents here and the zeros of the tangents. Okay, that this is the tangent at this point, suppose this is the tangent at this point, and we consider, since these tangents are all straight lines, then we can easily solve this or find the zeros or solutions of roots of this equation of the tangent. So those will give these points. Okay, if you consider the tangents and try to approximate this tangent to this point, then this will coincide to this 0. Okay, so in the numerical solutions of the system of linear equation, or a or an algebraic expression, or transcendental equation, or transcendental expression, you can easily use these numerical methods. Okay, and we can use numerical analysis as a to find the numerical solution of system of nonlinear equations as well. If this that means if this equation is y is equal to some x square plus sine x plus 2, then still you can use this formula, this idea. Okay, and one other area of the mathematics in which this numerical analysis is used is solving the differential equation and integral equation. Okay, so in this course of this numerical analysis, we will discuss such things in our syllabus, and the next class onwards we will discuss some fundamental definitions and some kind of operators to help this numerical method so easy. Okay, thank you.